The ocean sits 7 meters above a man walking home in Rotterdam right now. One wall is the only thing standing between them. 26% of the Netherlands should be underwater. 17 million people live there anyway, and most of them barely think about it on their way to work. Somewhere in Zeeland, a cargo ship sails above a highway. Not next to it, above it. Under Dutch law, that ship has the right of way because the sea lane above the road was there first. None of this happened by accident. A country decided on purpose to keep living below the ocean and then spent 90 years building the machinery to make that survivable. To understand why any of this exists, you have to go back to one night in 1953. The North Sea funnels every serious storm straight at the Dutch coast. On January 31st, 1953, a storm formed off Iceland and pointed itself directly at the Netherlands. By 4 in the morning, the dikes started breaking, while entire villages were still asleep. By the time the sun came up, 1,836 people were dead. One night wiped out more than 300 people in a single village before dawn. A ship's captain rammed his own vessel into a crumbling dike to plug the gap and save the town behind it. 150,000 hectares sat underwater by morning. 17 days later, the Dutch government made a promise. Never again. There was already a man who had spent 20 years warning them this was coming. His name was Johan van Veen, and he'd been telling anyone who'd listen that the country's dikes weren't strong enough for a storm exactly like this one. Almost nobody acted on it until the water proved him right. He didn't live to see the country finally build what he'd been asking for, but the plan the Dutch built afterward carried his name and his math for decades. That plan wasn't the country's first attempt at fighting the sea, though. Long before 1953, an engineer named Cornelius Lely had already tried something people called insane, closing off an entire inland sea with a single straight dam. The Zuiderzee was a shallow, violent bay eating into the middle of the country. Lely's plan was to wall off 32 kilometers of open water in one continuous line, turning a dangerous sea into a calm, freshwater lake. 10,000 workers and dozens of dredges built it from 4 points at once, meeting in the middle, piling up tens of millions of cubic meters of sand and clay pulled straight off the seabed. Woven mats of willow branches went down first to keep the clay from washing away before it could settle. Shipworms ate straight through the first wooden foundations, forcing engineers to rebuild parts of it with basalt, the hardest volcanic rock they could get, stacked by hand in the middle of winter in the sea. The final gap was 50 meters wide, with the tide still running hard through it. Crews had one shot: close it during slack water, the brief pause when the tide stops moving in either direction. Barges dumped fill as fast as they could, while the gap shrank meter by meter until it sealed. An entire inland sea got cut off from the ocean in a single afternoon in 1932. That wall, called the Afsluitdijk, is still holding the North Sea back today. Locking the sea out was only step one. The Dutch didn't just want to keep the water away, they wanted the land underneath it back. What's now the province of Flevoland was open water as recently as 1940. Engineers ringed off sections of the newly calm lake with smaller dikes, then pumped them dry, watching a seabed nobody had seen in 10,000 years rise out of the water centimeter by centimeter. The first stretch they drained got flooded on purpose by German forces in 1945, and Dutch engineers drained it a second time because there wasn't another option. Once the land was dry, it kept trying to sink because draining clay soil compacts it. Engineers had to leave some water in the ground on purpose, just enough to stop the compaction without letting the sea back in. 3 pumping stations have been running non-stop since 1942 to keep that province dry, and they haven't stopped once. If they ever do, the land goes back under. That project taught Dutch engineers almost everything they needed for the far bigger job the 1953 flood forced on them: a full coordinated barrier system across the entire southwestern coast. A program that came to be called the Delta Works. The early Delta Works dams followed a formula that worked. Build a massive concrete box on land, called a caisson, float it out to sea, then sink it into position and fill it until it becomes part of the dam. Engineers used that trick more than a dozen times along the coast, fighting tides that spun the caissons out of control mid-sink until seabed anchors and steel cables learned to hold them straight. Then the Dutch ran straight into a problem their own plan had created. One of the last major gaps left to seal, the Oosterschelde estuary, It was also home to a huge shellfish industry and a rich tidal ecosystem that had existed there for centuries. Sealing it completely with a solid dam, the way every earlier project had done it, would have killed everything living inside almost overnight. Fishermen, ecologists, and engineers fought over it for years. Local shellfish farmers fought just as hard as the ecologists did, warning that a sealed estuary would kill their entire industry along with the wildlife in it. In the end, the country scrapped a nearly finished solid dam and started over, building something nobody had ever attempted. A barrier 9 kilometers long made of movable steel gates instead of solid concrete, open on calm days, closed only when a storm actually threatens. Building it meant creating an artificial island in the middle of the estuary just to support the construction. 65 massive concrete piers went up one at a time over 5 years, each one cast to within centimeters of its design, then lowered onto mats on the seabed 30 meters down using nothing but GPS positioning and 2 custom-built ships made for that single project and never used again. 62 enormous steel gates, each one wider than a 10-lane highway and heavier than a loaded cargo plane, hang between those piers on their own self-contained motors, ready to drop shut in minutes. On October 4th, 1986, Queen Beatrix gave the signal, and all 62 gates dropped at once, sealing the last gap in the Delta Works while keeping the tides and the ecosystem alive underneath it. In nearly 40 years since, the barrier has closed to hold back a real storm roughly 30 times. It has never lost. Rotterdam, though, needed something the Delta Works engineers had never built before, a barrier for one of the busiest shipping lanes on Earth, one that had to stay open for cargo traffic almost all the time and still seal shut in hours. When a real storm showed up, the answer is called the Maaslankering, and it works almost nothing like the barriers before it. 2 hollow steel arms, each one longer than the Eiffel Tower is tall, sit open on opposite banks of the river most days, letting ships pass freely between them. When a storm surge threatens, the arms swing shut across the entire river, fill with water, and sink on to the riverbed to seal it completely. A computer system called BOS makes the actual decision to close it without a person pressing a button, because a storm surge can build faster than any human approval process. During construction, engineers floated one 6,800-ton steel gate for the first time and found it sitting more than 30 centimeters out of level across its full length. A serious problem on a structure that precise, and they fixed it by shifting ballast between 26 separate internal compartments until the whole structure balanced within 15 millimeters. The barrier has triggered for a real storm twice, once in 2007 and again during Storm Pia in 2023. Both times, the port stayed open until the last responsible moment, then sealed itself shut and reopened once the danger passed. Not every town along the water could afford steel gates the size of a highway bridge, though, and the Dutch found a completely different answer for the smaller waterways: rubber. At a place called Bramspol, 3 flat rubber and Kevlar bladders sit invisible on the riverbed most of the time, doing nothing at all. When a storm approaches, they fill with air and water and rise into a wall more than 10 meters tall in under an hour, protecting well over 100,000 people behind a channel too wide and too minor to justify a steel barrier. During one real storm test, the water outside came within 90 centimeters of overtopping it, close enough that engineers redesigned the backup systems immediately afterward. It has never failed since. The most recent Dutch answer to the ocean doesn't look like a wall at all. Near The Hague, engineers dumped over 20 million cubic meters of sand into the sea in a single spot, and then simply walked away, letting ocean currents spread it naturally along the coastline over years, instead of trucking sand in every few years the old way. It's called the sand motor, and the waves have been doing the actual construction work for free since 2011, spreading that one sand deposit along miles of coastline instead of trucks doing it by hand every few years. Even that wasn't the last shift in thinking. More recently, instead of building the walls higher, Dutch engineers started giving rivers more room to flood safely on purpose, digging new side channels through farmland so a river has somewhere harmless to spread out before it ever reaches a city. One new channel alone can drop a flood's peak height by close to 30 centimeters, enough on its own to keep water out of homes that would otherwise be underwater. After Hurricane Katrina flooded New Orleans in 2005, American engineers went straight to the Netherlands to study exactly this system, and Dutch water engineers have been advising on U.S. flood protection ever since, from Louisiana's levees to storm planning in New York and New Jersey. A country smaller than West Virginia turned staying dry into an export. 0 flood deaths in the Netherlands since that one night in 1953. Not because the storms stopped coming, because a country that refused to retreat from the ocean spent 90 years building the machinery to meet it instead. Would you trust a computer to decide when to seal a barrier against the sea, with no human in the loop? Tell us in the comments. And if you want to see the next country doing something nobody's tried before, subscribe, and we'll keep looking.